Hello everyone, and welcome to the Airflow Summit 2025. My name is Sungji, and I'm a staff backend engineer on the orchestration platform team at Coupang. Today, we'll share how we scale Airflow beyond 20,000 DAGs and why this requires a fundamental shift in architecture. We'll talk about the challenges of large-scale orchestration, the solution we built, our DAG Management Service, DMS, and the trade-offs of adopting a centralized model. Here's a quick overview of what we'll be covering today. First, I will set the stage by explaining why scaling Airflow beyond 20,000 DAGs isn't just difficult, it requires a fundamental shift in how we think about orchestration. Next, DaeHoon and I will walk you through the core architecture principles behind DMS and highlight the key features that make it work at scale. Finally, I will wrap up by summarizing the benefits of centralization, but also be candid about the critical risks and trade-offs that come with this approach. By the end of this session, you will have a clear picture of why we built DMS and how it works and what you should consider if you're thinking about adopting a similar model. Our story started with a familiar problem. A single Airflow cluster couldn't keep up as workloads grew. To address this, we moved to a multi-cluster environment. At first, it felt like the natural way to scale, but we soon realized that this approach introduced a whole new layer of complexity. This section explains those challenges and why they pushed us to rethink orchestration entirely. Let's put things into perspective. We run a hybrid cluster environment. On one side, we have shared clusters for core business functions. To meet strict SLAs, we have even had to deploy an additional Airflow cluster running version 2.9.3 alongside the existing version 2.4.3. On the other side, demand for team-specific clusters has been growing rapidly as these clusters give users more autonomy and control. This demand led to the creation of new clusters spun out from our shared environment. In addition to that, we also inherited several user-owned clusters, each running different Airflow versions like version 2.7.1 and version 2.9.0. Now combine this hybrid model with the scale of our operations, over 20,000 DAGs, active DAGs, and a 99% SLA target. What you get is a complex and fragile ecosystem. The truth is, the single cluster approach was never designed for this scale. We've exceeded no limits like we're using AWS. AWS's managed workflows for Apache Airflow caps at 4,000 DAGs, and that created a fundamental scalability challenge. This complexity hit both users and the platform team. For users, the biggest pain points were performance and reliability. DAG processors were under heavy load with CPU usage exceeding 90%. Slow database queries caused delays. DAG runs became unpredictable. And then came the noisy neighborhood problem. A single backfill job could disrupt the entire cluster, blocking other DAG runs and causing us to miss our 99% SLA target. But these user-facing issues were just symptoms of deeper platform challenges. A version upgrade became a nightmare. With more than 20,000 DAGs, a version upgrade turned into a high-risk, months-long project. And without CI and CD, automation was nearly impossible. And multi-cluster management added another layer of complexity. We are juggling connections and variables and configurations across multiple clusters, both shared and team-specific clusters, where the number of clusters kept growing. This increased operational overhead and created an environment front to human error. The bottom line, without a new approach, it became impossible to scale reliably. Now, DaeHoon will show how we solved with this DMS, our centralized DAG management solution.
Hello, I'm DaeHoon, and I know it's hard to pronounce my name, so just call me David, it's all fine. Thank you, Sungji, for setting up the stage and explaining why DMS is needed in our environment. And I'm very excited to walk you through DMS in detail, so let's keep going. So DMS, as Sungji also mentioned, is an architecture built to address a very common challenge, managing a multiple Airflow clusters. When operating several clusters, operational overhead and its complexity can become a significant bottleneck. So DMS wants to solve this by providing a centralized platform that transforms a fragmented multi-cluster setup into a unified and manageable system. So these are the capabilities of DMS. And the first core capability of DMS is a centralized DAG deployment using an external DAG processor. By introducing a centralized and external DAG processor, DMS can operate DAG processing in a much efficient way. And the second key feature is a seamless DAG migration. Since DMS has all the metadata, migrating a DAG from one cluster to another is quite straightforward operation. And the third major benefit tackles a well-known pain point on Airflow, managing a secrets like connections and variables. So in summary, DMS simplifies the world of multi-cluster environment by centralizing a DAG deployment and enabling a seamless DAG migration, and also standardizing a secrets management. Let's take a look at each component. Here are the brief architecture diagram of DMS. As you see, DMS is not just a Python web app or SDK. It's more like a comprehensive platform to manage Airflow clusters. It has several integrated components that work together to solve the challenges we mentioned earlier. So, a DMS pipeline is initiated by a GitHub pull request. A PR acts as a trigger, and there's a merge event created by this PR. So there's a changed file in a PR, and that is the primary target for DAG processing. So when a PR is created, user can trigger a DMS pipeline by leaving a comment like /merge. Then GitHub Action Bot detects this and creates a merge event. Merge event contains an information on changed files, so the external DAG processor then processes the files to create a DAG metadata. Let's take a look at core components on DMS, DAG processing system. It consists of two parts, the external DAG processor manager and the external DAG processor. The manager continuously pulls an unprocessed merge event, then creates an external DAG processor for each merge event. Then the external DAG processor parses and validates the files in a merge event to create a DAG metadata, such as DAG and DAG code records. The external DAG processor can also support multiple Airflow versions. It's possible because DMS knows which GitHub repository is mapped to which Airflow cluster. So when parsing a merge event, DMS can determine which Airflow version it should deploy to. So you just need to create an external DAG processor, adopting a DAG processing logic of each Airflow version. So by this, DMS can support multiple Airflow versions. So there's another key component called the serialized DAG updater. It is built for DAGs that are created dynamically. So these DAGs need updates even if the files haven't changed. So it's more like the original Airflow's DAG processor role. So you can consider this as a lightweight DAG processor for each cluster. Likewise, the updater periodically scans the DAG directory. However, the important thing is that it is lightweight. It's lightweight because it did not fully process every files. It only focuses on the files that have been created at the external DAG processor layer. So it's much more efficient on parsing. There are many more components on DMS, but today we're gonna focus on the DAG processing system and how it's a powerful solution for our larger scale environment. So the main difference between a traditional Airflow setup and DMS lies in how DAG processor works. This is the key to understand how DMS solves performance bottleneck and improves the efficiency, especially a parsing efficiency. In traditional Airflow setup, each Airflow cluster needs its own DAG processor, and DAG processor periodically scans the DAG directories and parses every files to create a DAG metadata. This kind of approach has some drawbacks. First, a high resource consumption. The more files to parse, the heavier load on the system. So it's quite obvious that the DAG processor is one of the most resource-intensive components, especially CPU resources in Airflow environment. The second is inefficient scanning. In large-scale environment, With over 20,000 DAGs, the number of files to process is massive. And Airflow's method of looking through every file is literally inefficient. While Airflow has some optimizations, like it provides a configuration to adjust the parsing frequency. And Airflow itself has been evolved by decoupling a DAG processor outside from scheduler. However, still, each cluster needs its own DAG processor, and DAG processor still needs to periodically parse full files. DMS want to go further. DMS want to solve this by moving the DAG processor outside Airflow cluster. So now, DMS operates DAG processing centrally and event-driven basis. So even if you add more clusters, you don't need to install an additional DAG processor for each clusters. So instead of periodic scanning, this approach, like centrally and event-driven basis DAG processing, really cuts down the resource waste and improves the efficiency. So here's a quick demo on how DAG is deployed, onboarded, and DMS. So let's see. As mentioned, DMS is triggered via a GitHub pull request, and user can leave a comment like /merge to trigger a DMS pipeline. So when it is triggered, behind the scene, the external DAG processor parses and validates the changed file in this merge event. See, the report has been submitted. So DAG metadata has created, and you can check all the DAGs in here. It is called Airflow Studio, a UI to manage your DAGs onboarded on DMS. Here, you can deploy the DAG to any clusters. In this demo, we deploy to a Taiwan cluster. Also, you can pause this DAG on and off in this Airflow Studio UI. And then the DAG have been activated on the target cluster we have been deployed to. DMS is not just a technical efficiency. It also provides a significant advantages on governance perspective. DMS has all the metadata, so it becomes a single source of truth for all your DAG metadata. When you have to find the DAGs that have some misconfigured values, previously, you have to search every clusters manually. But in DMS, you just need to check a single endpoint provided by DMS to identify the issues and check if there are any misconfigured DAGs. So it's much easier and it's much easier and faster. Not only a metadata consolidation, but also it can proactively enforce the governance. Imagine there are shared clusters where a stability is a key priority. What if user create a DAG with unreasonably high value of concurrency? It can overload the clusters and threaten other DAG stability, which is a common classic noisy neighborhood issue. But in DMS, especially at external DAG process layer, we can validate a governance-related metadata such as concurrency and even automatically correct this. So even if a user create a DAG with incorrect value, DMS can now systemically validate and fix the issues. So by this, DMS can manage a strong governance on multiple cluster environment. So let's move on to the next key features. I hope you all remember, is a seamless DAG migration. We developed this to address some complicated challenges, replacing a cluster. There are many reasons you want to change a cluster, and the most common and the most difficult one is a version upgrade. Airflow community is really vibrant and keeps evolving. And data engineers are always eager to use a latest feature provided a higher version. However, in any migration, the key challenge is a seamless migration. The DAG should run continuously and without duplications. Let's take an hourly DAG as an example. The DAG runs successfully at noon on source cluster. After cluster is replaced, the same DAG should run exactly at 1 p.m. without a duplication. However, it is harder than it sounds because we have seen many cases that duplication do occur because of a user's DAG configuration and Airflow's intended scheduling logic. So DMS solves this with a metadata management. By manipulating a DAG metadata on both source and target cluster, we can achieve a seamless DAG migration. So let's see the details. Here, the overall flow on DAG migration occur in DMS. So users should initiate a DAG migration, and it is done at the Airflow Studio we had saw at first demo. And then DMS checks whether the DAG is running on source cluster or not. If it is, it waits till the execution is finished. After it is finished, turn the DAG off. Prevent any new DAG runs from starting. The next two parts, like an extract metadata and copy metadata. This metadata management is the core concept on DAG migration. The metadata should be extracted from source clusters and then migrated to target cluster. The examples of metadata are a latest DAG run metadata and related task instance metadata and the next scheduled run metadata. After these records are inserted in target clusters, then turn the DAG on. With these steps, now target cluster can fully recognize the latest state of source cluster. So the DAGs on the target cluster can run at the very next scheduled time. So seamless DAG migration is achieved. I also prepare a demo on a DAG migration, and let's see too. User should trigger a DAG migration on Airflow Studio. When turning on the DAG, if there's a running DAG in another cluster, notification pops up and asks user to whether migrate or unpause. So stop it here. You can check the migration status at Airflow Studio UI, and behind the scene, the metadata have been extracted and loaded into the target cluster. Left side is a source cluster, and the right side is a target cluster. The information like DAG run and task instances, and even the next scheduled run time has been migrated from source cluster to target cluster. So the DAG on target cluster will be run exactly at the next scheduled time. Here are the queries they used for migration from 2.4 to 2.10. We are all excited to use Airflow version 3. So in DMS perspective, what you're gonna do is just find the right metadata query for extraction and loading. So let's move on to the next key feature. It's a standardizing of metadata secret management, which is lead. I'll hand over this.
Thanks, DaeHoon, for walking us through the architecture behind DMS and how DMS handles DAG processing and migration. Now that we understand the technical foundation, let's shift our focus to what this means in practice. I will walk you through the operational challenges we faced in multi-cluster environment and show how DMS addresses them with centralized secrets management. Managing a Airflow scale across multiple clusters is no smooth fit. One of the biggest pain points we faced was the decentralized management of secrets is critical components for every DAG. Without a central system, each cluster maintains its own secrets, creating complexity and risk. Think about it. A simple change like updating a credential requires manual updates across every cluster. This process was not only time-consuming, but also highly prone to human error. If we had 10 clusters, that means 10 separate versions of the same connection. And the risks didn't stop the centralization and introduced multiple challenges. First, inconsistency. Different teams managing on their own secrets often led to mismatched settings, causing workflows to fail. Second, misconfiguration, especially when teams manually define their own configuration like JSON payload in the extra field. A small typo could break an entire DAGs. Third, security. Credentials were sometimes stored in less secure ways, making compliance harder. And finally, scalability. Every cluster means repeating the same set of work, making slowing onboarding and increasing operational overhead. Clearly, decentralized approach was neither scalable nor sustainable for our global operations. So how did it address this? How do you solve this? To effectively address this pain point, we developed a centralized solution called the Coupang Secret Backend. Instead of each cluster owns its secrets, DMS now acts as a source of truth for all of them. We leveraged Airflow's built-in capability to integrate a custom secret backend. This allows every Airflow cluster to retrieve secrets directly from a single unified repository through the DMS API. The key benefit here is what we call multiple markets. With the DMS in place, a single DAG can run seamlessly in any cluster without any code changes. Here's how it works. Imagine a DAG that needs to connect to a market-specific database. Instead of embedding complex logic in the DAG, we define a single connection variable, say, database underscore URL. DMS then automatically maps the key to the correct database URL for the market where DAG is running, whether that's Korea, Taiwan, or Japan. This completely eliminates the conditional logic inside the DAG code, dramatically simplifies the maintenance, and ensures true infrastructure parity across all markets. It also enables rapid onboarding for new markets and delivers global consistency without duplicated engineering effort, which is directly supporting Coupang's globalization tenets. To make this even more powerful, we built a centralized UI interface that provides dedicated pages for managing all secrets in one place. This UI also supports market-based management, allow users and the platform engineers to define distinct values for each market. And this ensures both flexibility and without sacrificing consistency. Let's have an example for connections management page. We focus on delivering an optimized experience with type-specific input forms. This means users only see fields relevant to their needs. For example, EMR, both, and Select connections have each tailored input forms, making configuration intuitive and in reducing errors. Finally, to strengthen security and governance, we implemented team-specific permission controls like RBAC, and this ensures granular access management and enforces proper segregation of duties across multiple teams. We've just walked through the architecture and key features of DMS. Now let's take a step back and look at the bigger picture. What does centralization really mean for us? In this next session, we'll explore both sides of the story, the major wins we achieved, and the critical risk we need to manage from now on. Let's start with why centralization is such a big win for us. First, resource efficiency. Traditionally, every Airflow cluster runs its own DAG processor with high-speed, CPU-heavy. By taking out this load and making it event-driven, DMS is free from redundant parsing and dramatically reduces resource consumption. Second, unified governance. By centralizing all DAG metadata, DMS gives us a single point for managing and monitoring the status and configuration of every DAG. This strengthens governance by making it easy to identify and control DAGs without abnormal settings. And third, deployment flexibility. DMS decouples DAGs from cluster environments. Users are not tied to any cluster anymore. They can selectively deploy DAGs to any cluster they want because DMS holds the DAG metadata and adapts them to fit any Airflow cluster. This removes environmental constraints and gives us a true flexibility. These are powerful advantages, but centralization also introduces a critical risk that we need to address. Here's a trade-off. Centralization may create a single point of failure. What does that mean in practice? If DMS goes down, DAG deployment and migration stop. Existing DAGs, the good news is that existing DAGs will continue running on their clusters, but our operational agility takes a hit. So how do we mitigate this? In our case, high availability is now optional. It is a must. So we have built redundancy, variable mechanisms, and proactive monitoring into the design to ensure 24/7 stability. Despite this risk, adopting DMS is a highly strategic choice for any environment that needs to manage large number of DAGs reliably. The benefit it brings, such as resource efficiency, strong governance, and flexible deployment, fundamentally solve the complexities of large-scale DAG management. And when you pair DMS with a robust design, robust high-availability design, the advantages far outweigh the drawbacks, and making it an essential tool for any multi-cluster Airflow environment.